Memorization.
Okay, the first note is just memorize. This is just practice. This isn't a packet. You already had the stuff memorized.
Do we not have options?
Tomorrow, 2 hours away.
No.
Tomorrow's not a 2 hours.
Okay.
Do you mean tomorrow?
Check your email. They got a weird schedule going on, and I don't think I have Alpha yet until Monday. But you check and see what you think. I don't know. I'll be here and you show up if you're supposed to. I'm gonna pass. All right. So here we are. And again, these aren't numbered, but we're starting on the first one that says something plus cosine squared is 1. What goes in this blank? Sine squared. Make sure you put sine squared. The Pythagorean identity, sine squared plus cosine squared equals 1. Okay? Now, how about the next one? 1 over, that's one of your reciprocal identities. So what does secant equal?
1 over cosine.
1 over cosine, exactly. That's an old one. That's one you've known for a long time. Now, here come one of the new ones that we just talked about. When you have a 90, you think complement co. So the co-function for cosine is sine. So it's just sine x. Now we've got another new one. We talked about these yesterday. When you have a negative,
Goes in the front.
the negative goes in the front for everything except cosine and secant. That's not a cosine or a secant, so it's going to be negative cosecant. Negative cosecant. Tan, got 2 different definitions here for tan. What's one of them? Sine over cosine. That's probably the most important one. But the other one is 1 over cotangent. The reciprocal of the cotangent. Now we have another one with a 90 in it. Remember, when you see the 90, you think complement, you think co. What is the co for cosecant? Not the reciprocal. I didn't say the reciprocal. The co-function. Cosecant. The reciprocal, or the co-function is the secant. The co-functions are the cos. Secant, cosecant, tangent, cotangent, sine, cosine. Those are the co-functions. When you see the 90, you think co-function. 1 plus what is cosecant squared? 1 plus cotangent squared is cosecant squared. Another negative, cosine negative x. We remember with the negatives, we just pulled the negative out for everything except cosine and secant. So therefore, the negative just goes away, and it is cosine x. Sine squared plus cosine squared equals 1. And sine is the reciprocal of what? 1 over means reciprocal. Sine is the reciprocal of cosecant. You've known that one for a very long time. All right, now we got the back side. Okay, here we go. So we got another negative. We either drop the negative or we pull it out in front. The only time we drop it is if it's a cosine or a secant. This is not a cosine or a secant. So therefore, what happens to the negative? Comes out in front. Cosine is the reciprocal of secant. Sine squared plus what is 1? Cosine squared. 1 plus what is secant squared? Tangent squared. Sine negative x, what happens to the negative? Negative sine, exactly. What's the cotangent? Two definitions.
1 over sine over sine.
One of them, the most important one, is probably cosine over sine, but it is also 1 over the tangent. Secant.
Would you ask for both?
90 minus x. Secant, 90 minus x. Cosecant. Because 90 is your clue, it's a cofunction, and the cofunction for secant is cosecant. Cosine negative x. Didn't I just do this? Cosine negative x is cosine. Sine is the reciprocal of cosecant. And the cofunction for cotangent, the cofunction for cotangent is tangent. And then I snuck in a little review problem here that I also snuck in on your quiz. So you're going to need a calculator. 48 5x. So we got a little right triangle. This is not new. This is old stuff. So what do you need to do here? You need to look at this equation, this picture. Look at this picture and figure out whether it's going to be a sine, cosine, or tangent equation. So I hear a bunch of sines, and you are right. The sine of 48 equals 5 over x. How come it's a sine? Because this is the opposite, and this is the hypotenuse. So we're going to use sine 48 equals 5 over x. The sine of the angle equals opposite over hypotenuse. So to solve that, we'll multiply by x, and then we will divide by sine 48. Now, I have no idea what you've been doing with your calculators. Let's make sure it's in degree mode, because that is a 48 degrees. So we're in degree mode. So 5 divided by sine 48, 6.73 is my answer. Next time I see you, we are going to have a quiz that's going to look exactly like that. It's going to have 10 definitions, or not definitions, but 10 memorization things, and then that little review problem. Okay? And we just practiced 4 pages of it. You've got to get it memorized by the next time I see you, which I think is Monday, but not sure. Okay. The time after that, so the time after next time, we're going to have a quiz that has some of these other kinds of problems on it, these simplified problems. So get out your other extra practice sheet here. And we have worked through the first 10. We're going to try to get through the rest of these today. We should be able to. Now, we're going to go through these in a little bit different order. On the quiz we take, so I only have 2 problems on it. And one of the problems is going to look like problem 13. Problem 14. We'll start with those 2 first. We'll do a couple more. So one of the problems on your quiz, that you got memorization quiz next time, then you've got your simplification quiz. And one of the problems on the simplification is going to look like this. Just functions in a line all times each other. Okay, so who remembers from yesterday, what did we do when we had these lines of functions times each other? We wrote them as fractions. So tangent squared would be Sine squared over cosine squared. What's cosecant squared? 1 over sine squared. And then we can see a cancellation here. So we have 1 over cosine squared, which could also be written how? What's 1 over cosine? Not cosecant, secant. So 1 over cosine squared is secant squared. So your job was to simplify. Your job was to simplify. So we took this guy, we wrote it as fractions, canceled some stuff out, and we're left with that. Okay, what about this one? What did we say we were going to do with sines and cosines? Just leave them, right? Because the idea is we're going to hopefully be able to cancel them out when we rewrite these other things. So I'm just going to make that sine over 1, or yeah, sine over 1 and cosine over 1. Now what am I going to do with tangent? Sine over cosine. And what am I going to do with cotangent? Cosine over sine. I think all we have left is sine cosine. And that's not going to simplify anymore. We're done. We're done. They won't cancel each other out. Okay, so that was 13 and 14. Let's look at 18. One of your quiz questions is going to be exactly like this long string of stuff. So we're going to write in as fractions. So Max, what do we do with this guy?
You're going to single them out. You're going to write a fraction for that one. So
what fraction would this be? It's a
sine over 1.
Sine over 1. And
Cosine over 1.
Yep.
Sine over cosine.
Yep.
Sine over cosine over sine.
Cosine over sine. And 1 over cosine. So those cancel, those cancel, those cancel. So just sine. That one boils down to just sine. Alright, there's a couple more. Let's do the other ones here. Let's do 19. 19, just a string of functions times each other. So what are we doing with sine squared? Leaving it as sine squared over 1. What are we doing with secant? 1 over cosine. And cotangent squared?
Cosine over sine.
Cosine squared over sine squared. Now, I'm hearing people say, write this as 1 over cosecant squared. It is 1 over cosecant squared, but I'm not going to write it that way. What am I trying to do here? What's the point of writing all these fractions? Canceling. If I don't get them all into terms of the same function, I'm not going to be able to cancel, right? It's not going to help me to change this one into a cosecant and this one into a tangent. That isn't going to help me. I could do it. That wouldn't be wrong, but it's not going to take you to a simplification. You're not going to be able to get an answer. Your goal is to do what with each of these? Break them down into sines and cosines so that they will be like terms and you can start canceling them out. Changing them into other things isn't going to help you. You want to be able to cancel. And changing them this way, I can cancel. What happens here? One of them cancels, so I'll be left with just cosine. Right?
Yep.
With these problems that are written out as these long strings, you want to get them all broken down into sines and cosines so that you can cancel. Okay, so that was 19, so let's do 21. and 23. Okay, we're doing all of the problems that are these long strings of functions times each other. Our strategy is to break them down into fractions with sines and cosines. So what's this? Sine over cosine. Times 1 over cosine times 1 over sine. So those cancel. 1 over cosine squared, which could be also written as 1 over cosine is secant squared. I would probably take that one, okay? All right, how about this one? What do we have here? We have 3 over 1 times sine over cosine times cosine squared over sine squared. So one of the sines will cancel, one of the cosines will cancel. So I have 3 cosine over sine, or 3 cotangent. The 3 just hangs around, it doesn't, nothing happens, it just comes along. Okay, so to simplify problems, if you have a long string of functions all times each other, what are we going to do? What have we done in all of these? Every one we just did. Break them down into fractions as sines and cosines, and then hopefully stuff will cancel out, and you'll have a nice, simple answer. Okay? Now, the other kind of problem is not written like that. The other kind of problem is written like number 11. Do you see how this problem looks different, you guys? Structurally, that's just different. All the ones we just did were long strings of functions times each other. This is not. This is some division problem. Okay? So with these, you need to be thinking about your Pythagorean identities. And some kind of substitution, probably. You're probably going to have to do a substitution with your Pythagorean identities. Okay? You can do it a couple of different ways. A very, very straightforward way is to say, right here I got a secant squared. Over here I have a secant squared. What does secant squared equal? What does secant squared equal? It's written right there. 1 plus tangent squared. So I'm going to take out my secant squared and I'm going to write 1 plus tangent squared in its place. That's a straight substitution, like you've been doing since freshman year. Now, what happens down here when I start collecting like terms? The ones cancel, and I have tangent over tangent squared. So now one of the tangents will cancel, and I have 1 over tangent left as my answer. And what's 1 over tangent? Cotangent. So what was my strategy with that kind of problem, a problem that looks like that? I use my Pythagorean identities and I do some kind of a substitution. Now, why did I know in this whole problem, why did I know that I was going to substitute for secant squared? Why didn't I substitute for tangent? Because it's not squared. Look at your Pythagorean identities, guys. Is there anything in there that's not squared? No. So you're going to be substituting for the squared one. So we're using those identities, substituting in here. All right, let's look at the next one. The next one that looks like that is 15. So 1 plus tangent squared over 1 plus cotangent squared.
Get over cosine.
What's this? Look at your identities.
Secant squared.
That's just secant squared, isn't it? So secant squared. What's this? Cosecant squared. Those are the actual identities. 1 plus tangent squared is secant squared, and 1 plus cotangent squared is cosecant squared. Those are the identities. Now, what is secant squared? 1 over cosine squared? So I'm going to think of this as 1 over cosine squared. And what's that? Cosecant squared? 1 over sine squared. These are fractions being divided. What do I do when I divide fractions? Multiply by the reciprocal. So that's 1 over cosine squared times sine squared over 1. Now nothing cancels, but when I multiply those, I get sine squared over cosine squared. Which is tangent squared. So this answer, the simplification final answer, is tangent squared. I know, it's hard. I know it. I know it. But we don't run and hide. We face it head on. We just keep plugging away, doing our very best. At the very least, you should be able to get from here to here. If you can't do that, you simply haven't learned your identities, because they're right there. I mean, that would be a very obvious first step. All right, what's the next one that looks like that? Which one was that? That was 15, 16, looks like the same thing. So what are we gonna do with 16? Those are cosines? No, cosecant CSC. These are cosines. So somebody has looked at the numerator and said that is sine squared. Now, if you can do that, that is awesome. Some of you, that's just too much of a reach for. Let's look over here and let's see. I got a cosine squared. Cosine squared. If I want to substitute for cosine squared, I'm going to have to subtract sine squared from both sides. So cosine squared equals 1 minus sine squared. Right here from this equation, I moved the sine squared over so that I could substitute for the cosine squared. So if I did that, I'd have 1 minus sine squared over 1 plus 1 minus sine squared. If I just went ahead and substituted for both of them. All right, now what happens on the top here? Remember, you're minusing, so that's going to be 1 minus 1 plus. Those of you that said the numerator was just sine squared, you're right. You shortcutted it. You did a great job. That's perfect. That's beautiful. Down here, the ones don't cancel though, so we got a 2. So we have sine squared over 2 minus sine squared. And that you really can't do anything else with. This is a problem that I would have to accept multiple answers because there are different ways of simplifying this. That would be one option. That would be one option. So if you had another thought, you might be right. This is not going to simplify like those other ones to one middle term. It's a harder problem. All right, 17. What about this one? Think about what we just did. Anybody have a thought? It is sine squared. The bottom is sine squared. Those of you that are wondering how they're doing that, take a look at this identity. If you subtract cosine squared from both sides, what does it say? Sine squared equals 1 minus cosine squared? So you have sine cubed over sine squared, which is just sine. That one's going to simplify to just sine. So in both of these last problems, we've used the idea that that identity can be rewritten like this, or like this, either way. Number 20. What do you think about number 20? What?
Is the denominator 1?
The denominator is definitely 1. The denominator is 1. So now we really just have this. We really just have this now because the denominator is just 1. So we just have this now.
The first half of it is secant squared.
What is secant squared? 1 plus tangent squared. So let's take the secant squared and let's replace it with 1 plus tan squared because that's what it is.
Tan squared cancel out.
Yeah. So the answer to the problem is just 1. Looked really scary, simplified to 1. And then we got number 22. How about that denominator? We've looked at him already a couple of times today. What's the denominator? The denominator is sine squared. Now the numerator, what? Yes, negative cosine squared. Now, for those of you that are thinking, whoa, wait a minute, that's too much. We figured out by rewriting this one that cosine squared was 1 minus sine squared. If you turn that around, you can do that, but it would make this negative. It's like 4 minus 7 and 7 minus 4. When you turn it around, it becomes negative. So what is cosine over sine? Yeah, so that's negative cotangent squared. I think we've done them all except number 12. Number 12 is a different kind of problem. What makes number 12 different? They're being added. That's different than the ones, the big long string where they're multiplied. These guys are being added. Okay, we're gonna go ahead and do it. It's not a hard problem, it's just different. This is number 12. Should be the last one. I think we've done all the rest of them. Exactly. So sine over cosine plus cosine over sine. Now, if this were one of those regular problems and this was a times, then everything would just cancel out, right? but it's not, it's a plus. What's different about how we handle a plus?
You need to find a common denominator.
Bingo, we need a common denominator. And since that's a cosine and that's a sine, the common denominator will be cosine sine, right? So I'm going to have a denominator that's cosine sine. So this one is going to need a sine. And this one is going to need a cosine. So my numerator is going to be sine squared plus, that's 1 over cosine sine. Okay? Now, turn it over and let's take a look at our first practice quiz. Now, what's the quiz next time? Just memorization, and that's like we practiced before, right? This is for the time after that. So we're going to have another day of practice before we do that one. But remember I said there were going to be 2 columns, right? And one is going to be a long string, and one is going to be one of these other kinds, all right? See how far you can get. Your first practice quiz. See how far you can get. Turn the page. Yeah. I said turn the page. There we go, right there. So practice quiz number 1, we're seeing how far we can get with it. By the way, in number 2, I used a theta as my variable. If that makes you uncomfortable, feel free to change it to an x. That's like in an equation, you can use n or x, whatever variable you want. You can use whatever variable you want here. So if you don't like making the thetas or they make you nervous, you can certainly change it to an x. Did anybody get number 1 simplified? Jordan, you did?
Yeah, 1 over tangent x.
You got 1 over tangent?
It was just tangent.
I just got tangent.
Just got tangent? Well, we don't know. We'll just have to see. Let's see. Jordan, what did you do with cotangent?
1 over tangent. Oh, never mind. I should have done it.
What are we going to do with this? Change it into cosine over sine. Let's just not be tricky. Let's just make it easy on ourselves and change everything, break it down into sines and cosines so that it will cancel out. So this is sine over 1. What's this?
1
over cosine. What's this? Sine over cosine.
My oh my.
Okay, Jordan, you with us at that point?
Yeah, I messed up. I know that.
All right, so what happens? Let's see. These are going to cancel. Those are going to cancel. And we're left with sine over cosine, which is tangent. How many of you got that right? Okay, now look how many hands are up. Yesterday, this seemed hopeless and impossible. And look, you just took a quiz and got the first problem right. All right? Now let's look at the second one. Anybody get an answer to the second one? Olivia?
No, but I got a question. Does that have to always go to 10x? We can't just leave the sign over cosine?
That's a matter of debate. Since that's so obviously tangent, I would like to see tangent. Okay? That's really a judgment call on the teacher's part. This is fine, but since we know that's tangent, we're trying to make it as small as we can, as simple as we can. Let's try to make it tangent.
And I got sine.
She got signed for the second one. How about the rest of you? Kaufman's
Yeah.
nodding.
Yeah.
If you got signed for the second one, you just got an A+ on this quiz, because that's what it is. Those of you that didn't get signed, take a look at this numerator right here. We have talked about that already today in a couple of different problems. If you take this main identity right here, you can rearrange things and come up with sine squared equals 1 minus cosine squared. So when you see a 1 minus cosine squared, you can always replace it with sine squared. So now you've got sine squared over sine, and that is just sine. Okay? All right, there's 2 more practice quizzes, but I'm going to save them for next time. We'll do those next time. We're going to do something a little bit different now. We're going to get our notes set back out. And our calculator. We must have a calculator. We'll need a calculator for the quiz next time. And we'll need a calculator for everything else we're doing in this chapter. Okay, so we're getting our notes, our regular notes out. We're on the back of page 40. And we're starting with section 5.5. This is 4. Why aren't we doing the middle of chapter 5? The middle of chapter 5 involves more problems like this, but several more identities that you would need to memorize. There are tons of different identities, a half angle, double angle, sum, difference, tons of them. And they're not critical to your life going forward, so we're not going to get all bogged down in that. I think it's fun, I think they're awesome, but it's kind of hard and not necessary. So we are skipping right to the necessary part, which is 5.5, and we're going to solve a triangle. So we're switching gears. I'm going to try to remember to do a little bit of memorization practice at the very end of the period to get us back in the swing of that. But right now we are going to solve this triangle. Does anybody know what I'm talking about when I say solve a triangle?
Solve an angle.
Well, if I look at this triangle, I know 2 of the angles. So there is a 3rd angle that needs to be found. I know 1 of the sides. There are 2 more sides that need to be found. So when we say solve the triangle, we mean find all the angles and sides. You will always be given 3 pieces of information. And then your job is to find the other 3. Now, the quiz you're going to take next time is going to have a picture on it that looks like this. Right? And your job is to find x. So is that a triangle? Do I know 3 pieces of information? Yeah. And you're going to find this piece. Now, that's where we used to stop. We used to stop finding that one piece. Now we're going to find all the pieces. We're just not going to stop. But let's go ahead and do this for review. How does this work? I need a sine, cosine, or tangent. So cosine. So I'll say cosine 58 equals 3 over x. So x cosine 58 equals 3, and x equals 3 over cosine 58. So you would tell me the answer is 5.66, and you're done. So you just solved for a part of the triangle. Now we're going to solve the whole thing. Now there are a couple of things I want to point out before we start. First of all, it is common practice when we label triangles, we use capital letters for the angles, and we use small letters for the sides. So when I label this side over here, it is going to be small b. It is small b because it is across from angle b. So this would be small c, and this one, even though I know it, this one is small a. That's the way triangles are labeled, just common practice. Big capital letters for the angles, and then small letters for the sides, and A goes with its opposite side. B goes with its opposite side. Okay? Now the second thing I want to point out, now that we know we got to find big B, little b, and little c. That's my job. If I'm going to solve this triangle, I have to find those pieces of information. I have a huge problem though, kids, because what I learned before isn't going to work. Can anyone tell me why I'm not going to be using that strategy right there?
It only solves for one part.
It's not a right triangle. It's not a right triangle.
Can we split it to this one?
And if it's not a right, hang on to that thought, if it's not a right triangle, then SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, none of that works because you don't have a hypotenuse, right? So we need a new strategy. Math teachers refer to this as our trigonometry toolkit. SOHCAHTOA is in that toolkit. But SOHCAHTOA only works if the triangle is a right triangle. If the triangles aren't right, we have 2 other tools that we need. And one of them is called the law of sines. And, Ferris, you're amazing. Because if I were going to take the time to derive the law of sines for you, I would derive it by dropping an altitude and splitting this into 2 congruent, or 2 right triangles. Now I'm not going to derive it, I'm just going to give you the law, but that's where it comes from. That's how we get it. We do exactly what you thought to do. The law of sines says this: sine of A over A equals a sine of B over B equals a sine of C over C. Everybody loves the law of sines. It's really, really, really easy to memorize, and it's really, really easy to use. The law of sines is a proportion. Sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. That's the law of sines. So easy. Now, let's look up here at our triangle. If we're going with the law of sines, you have to have an angle and its side. In other words, you have to be able to set up one of these fractions. I think I can do that right here. I'm going to say the sine of 38 over 16, the sine of A over side A. See that, everyone? Now that's going to equal I don't care. How about sine 70 over C? Does that make sense to everybody? Now, I can solve that. How will I solve that? It's easy. Yeah, cross multiply, right? So I'll cross multiply. So C sine 38 equals 16 sine 70. Just cross multiply. Now I want to get C by itself. So when I divide by sine 38, so what am I going to type into my calculator? 16 sine 70 divided by sine 38. Now, only one caution when you type this in. When you press 16 sine 70, it puts a parentheses here automatically. Make sure you close those. Divided by sine 38. Did you get 24.42? For side C? Nod.
Arnold, the angle's supposed to equal 180.
Oh my gosh, listen to Max.
I mean, like, it's just supposed to be ABC equals 180 or less, but like, I understand that, like, if you have
ABC
three
won't
angles.
be 180 or less. ABC will be 180.
Well, I just understand that, like, you know, you have three angles, aren't they all supposed to equal 180?
Uh-huh, yep.
So why is that less? Because I know if that all adds up, that's not 180.
That's the side. That's side C.
Oh, that's a side. Oh, okay.
That's side C. I know angle C is 70.
Yeah, I
Now,
got ahead of myself.
I can find angle B though. Do you understand what Max is saying? We can find angle B. Do we need anything fancy or tricky to find angle B? No. If that's 70 and that's 38, then this has to be 72. You don't need any trigonometry to do that. You got to remember from geometry that the angles of a triangle add up to 180, right? Now we're not quite done, but we're almost done. We have one more thing. We have to find side B. So we're going to say sine 38 over 16 equals what? Sine 72 over B. That is exactly right. Now, did anybody think about sine saying here, instead of using 38 and 16, were you thinking about sine 70 over 24.42? No. No, please don't, because that's rounded off. So let's not use that if we can help it. We're going to have some hard problems later on where we may need that, but right now let's just stick with the 38 and 16 as our first fraction. Okay? Now, cross multiply. B sine 38 equals 16 sine 72. I am not shortcutting. I'm writing down every step so that I don't make careless mistakes. Now I'm going to divide by sine 38.
24.792.
And I'll type in 16 sine 72 divided by sine 38. And I just caution you, please, please, please remember to close the parentheses after that 72. So Jordan's already given us the answer. Let's see if he's right. He said 24.72. You just solved your first non-right triangle. And that was not hard at all, was it? That is awesome. So I'm going to pause there. We'll come back and work more on that. Before, we got 5 minutes. Let's do a quick review of memorization. Before I erase all this, anybody have a question? We love our raw signs, except for one little snag we'll talk about next time. So we got this, okay? That problem? All right. I'm going to write some stuff up here. Let's just, if I were real cool and hip, I'd have like Kahoot or something. I don't know how to do that. So, I'm just going to write stuff up here, and you're going to shout out answers. Here we go.
Cosine.
don't shout out answers until I've written down the problem. Yes, a negative sign. Good. Tan X, that's a co-function. Very good. That's tangent squared. 1 plus tangent squared is secant squared.
Yeah, see, because we had.
Yeah, this one. What's that? 1 over secant. Good. I meant to write cotangent. What's cotangent? Cotangent. Cosine over sine. Or 1 over tangent. Good. Sine squared plus cosine squared. 1. 1 plus what is cosecant squared? Cotangent squared. Oh my goodness. Guys, these two are very, very similar. These two are very similar. And last but not least, because you're going to have to do this on your test, on your quiz.
Sine 53.
Tangent 53 equals.
Or sine is
Cosine
tangent. It's tangent. Tangent. Tangent 53 is x over 52, right? Tangent, opposite over adjacent. All right, next time I see you, we have a quiz like that. Be ready.